Happy Wednesday and welcome to your latest integral of the day. It is April 19th, 2023. You're watching Math TV with Professor V. I got a cute little trig integral for you guys. So pause the video if you want to try it on your own first. Otherwise, let's jump right in. I'm looking, since the denominator has sine squared t in it, and then I see one lonely little cosine t, I'm going straight for a u sub because I want cosine t dt to become my du. So in my mind, I'm going, ooh, this would be a lovely du. So then just think backwards. What would u need to be? U would need to be just sine t, not sine squared, okay? Don't put the exponent in there for the u sub. Now du will be cosine t dt, fabulous. And we're going to change our limits of integration right away. Don't delay on that. So currently these limits are in terms of t. So u of 0, that would be sine of 0, which is 0. That's my new lower limit. It stays the same. And then u of pi over 2, that's my upper limit. That would be sine of pi over 2, which is 1. So now we're ready to rewrite this integral in terms of u. It'll go from 0 to 1. Cosine t dt is just du over square root 1 plus u squared. Okay. Dang it. If this was a minus, we would be done because this would be sine inverse of u, but it's not. So since it's a plus, now it's time to use trig sub. Okay, which trig substitution is appropriate? We're going to use tangent theta. So now we're going to let u equal tangent theta, and now I'm going to rewrite my whole integral in terms of theta. So du is secant squared theta d theta. And then again, let's change our limits because currently these are limits for u, right? We need to change them to theta limits. So be careful. This time I'm not plugging in the limits for theta. No, these are u limits. So that means 1, this limit here, is equal to tan theta. So you have to think to yourself, okay, when is tangent equal to 1? At pi over 4. And then 0, my lower limit, is equal to tan theta. When does that happen? At 0. So when you do a trig sub, you take the limits and you set it for whatever variable is getting replaced with the trig function and solve for theta. When we did a u sub, it was the other way around. These limits were already t, we plugged them in. So just be careful. Always remind yourself, who do these belong to? And then just plug them in for the appropriate variable. Okay, now let's write another integral, this time switching to theta. So it's like we can't make up our mind. So we're going from 0 to pi over 4. Du in the numerator is secant squared theta d theta. And then we have rad 1 plus u squared, so that's 1 plus tan squared theta. Fabulous. Well, the whole point of doing trig sub is so you can use your Pythagorean identities to simplify what's underneath the radical. So we know 1 plus tan squared theta, well, that's secant squared theta, and then that's underneath a radical. So really, we have 0 to pi over 4 secant squared theta d theta over square root of secant squared theta, which for a hot second is absolute value of secant theta, but we restrict theta so we don't have to worry about the absolute value. It won't be negative. And then you can cancel out one of these factors. Lovely. And then we have integral 0 to pi over 4 secant theta d theta. And then here it just comes down to, you should have memorized this antiderivative. Oh yes, indeed. I show how to derive it in one of the videos, but it comes up so frequently and it's not a very naturally intuitive way to derive it. So just memorize this bad boy. ln, absolute value, secant theta plus tan theta. And then we're going to evaluate this from 0 to pi over 4. And then this is the best part too, because I can see if my students know any trig or not. So this is secant pi over 4 plus tan pi over 4 minus ln absolute value secant of 0 plus tangent of 0 And then let's see. ln secant of pi over 4, that's reciprocal of cosine pi over 4, which is 1 over rad 2. So take the reciprocal. Now it's just positive rad 2 over 1. Tangent of pi over 4 is 1. Minus ln absolute value secant of 0, same as cosine of 0, it's 1. Plus tangent of 0 is 0. And then look here. This is just natural log of 1, so that's 0. Goodbye. And then I don't need these absolute value bars because rad 2 plus 1, that's already positive. So our final answer is just natural log of rad 2 plus 1. Box it. Beautiful. So I hope you guys have a wonderful Wednesday. I'm on my way to ballet, and then I'm going to go visit my mother's calculus class, actually, before I head off to my own calculus classes this afternoon. Hope you enjoyed the integral of the day. Give the video a thumbs up. Subscribe if you haven't already. Check out the rest of my playlists for calculus 1, 2, and 3. And also, you can catch me on Instagram and TikTok at MathTV with Professor V. Take care, you guys. Bye-bye.